In this part of the video, we're going to practice some of those properties that we looked at in the first video. The product of powers property, the quotient of powers property, and the power of a power property. These are in your textbook as well as in your student journal. So I would be sure to go ahead and highlight them. The product of powers property is the one that said, if we have a to the m times a to the n, that's a to the m plus n. The quotient of powers property is when we had a fraction a to the m over a to the n, saying that we would subtract our exponents. And then the last one that we had on there was the power of a power, which is when you have a power outside of the set of parentheses and what that does. So if we look at this and we're using those rules that you have, we see that we have the base written twice. That's our reminder that we're going to add the exponents. 2 plus 6, so that's 3 to the 8th. For this one, we have negative 4 to the 2nd on top and negative 4 to the 7th on top. So we know that the rule said we would subtract, which gives us negative 4 to the negative 5th. But we want to only use positive exponents when we write these. So as our final step, we're going to go ahead and make that the reciprocal, negative 4 to the 5th power. Now, sometimes you're going to work that out and sometimes you're not. It depends. That's kind of a larger number. So sometimes you will and sometimes you won't. For this last one, we have a power to a power. We see that z is only written one time. So that tells me I'm going to use my rule where I multiply my exponents. So that's z to the negative 12th. Since I don't want to leave it with a negative exponent, I'm going to use that reciprocal rule and make it 1 over z to the 12th. So here's a few more for us to practice with. Here the base is written twice, so we're going to add those exponents. 10 to the 4th plus negative 6, 10 to the negative 2, so 1 over 10 squared. For number 6, we have the base written twice, so we're going to add 9 plus negative 9 is 0. So x to the 0 power is just 1. On number 7, we have a negative divided by a negative, and since they're not inside parentheses, it's not written negative 5 to the 8th. That means the negative is on its own, so a negative divided by a negative is a positive. Now we can do 5 to the 8 minus 4 is 5 to the 4th. For number 8, we have y to the 6th divided by y to the 7th, so we're going to do 6 minus 7 is negative 1. So y to the negative 1, and since it's a negative exponent, we're going to do 1 over y. Number 9, we've got a power to a power. We see the base is only written one time. That's what tells us we're going to multiply these. So 6 to the negative 2 times negative 1 is 6 squared. Since that's relatively small, we would go ahead and multiply that out. 36. For this one, we might go ahead back there on number 7 and write 625. For 10w to the 12th to the 5th, we're going to multiply, and that's w to the 60th power. The next section in your student journal has these practice problems. Why don't you pause the video and take a few minutes and work like 6 of them, and I'll put the answers up. So just pause the video, and then when you come back, the answers will be here for you to check. Okay, I went ahead and solved 9 through 20 for you. I noticed that 21 through 23 are what we're going to talk about on the next slide. So those don't really belong with this group of problems, but here are the answers for these. You want to check these and look through your work and see if what I did was what you did. You may want to pause the video again so you can check your work. I'm going to move on to the next slide. So here we're talking about a couple of new rules. The power of a product. So that means you're multiplying something inside and then taking it to a power. But what that means is both things inside get that power. It only works because this is multiplication. If that was addition or subtraction, this wouldn't work. So what it looks like algebraically is if you have a times b both being taken to that m power, that means a to the m times b to the m. And when we're talking about the power of a quotient, we've got 3 divided by 2. Both the 3 and the 2 get that power of 5. And of course, when we're talking about this with variables, we have to remember that b cannot be 0. Your denominator, we can't divide by 0. A can be whatever, but b can't be 0. So when we look at something like this, negative 1.5y squared, both the negative 1.5 and the y are both going to be squared. So negative 1.5 times negative 1.5 is 2.25, and then we have y squared. On this next one, we're doing the power of a quotient, so the a is going to get cubed, and so is the negative 10. So we have a to the third over negative 1,000. On C, everything in there gets that fourth power. So 3 to the fourth, d to the fourth, 2 to the fourth. So we have 81 d to the fourth over 16. And then for this last one, everything's being taken to a power, but you'll notice that it is a negative exponent. When I have a whole fraction taken to a negative exponent like that, what I do is I just go ahead and I do the reciprocal of the whole fraction, which will make my exponent positive. So this will become 3 over 2x, and then it will be to the positive 5th power. And then I'll distribute that positive 5. So that becomes 3 to the 5th over 2 to the 5th times x to the 5th. And we can work that out if we want. So that would be 243 over 32 x to the 5th. Just a couple more examples here. The more the better when we're dealing with these exponent rules. Here, everything's being taken to a negative power. So we have an option. We can either move it all together or move it separately. I'm going to move it all together. So I'm going to say 1 over 10y to the third. And then I'm going to take everything inside the parentheses to that third power. 10 to the third, y to the third. On number 12, everything is getting that 5th power. So if I have a negative to an odd exponent, I know my result's still going to be negative. So it's going to be negative 4 to the 5th over n to the 5th. On number 13, I'm going to do 1 to the 5th over 2 to the 5th. Now this k is squared. K squared to the 5th power, remember that's the rule where we multiply. So 2 times 5, that's going to give me k to the 10th power. 1 to the 5th is 1. 2 to the 5th is 32, so we have 32. 1 over 32k to the 10th. Here we have another fraction that has a negative exponent, so I'm going to do the reciprocal of the entire fraction, which makes my exponent negative or positive. So 7 squared over 6 squared c squared. So 49 over 36 c squared. Here's an example involving scientific notation. So we have a jellyfish emits about 1.25 times 10 to the 8th particles of light, or photons, in each 6.25 times 10 to the negative 4th second. How many photons does the jellyfish emit each second? So we're going to do 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative 4th. And we're going to use all of our rules here. We have numbers that have exponents with the same base here, 10 to the 8th, 10 to the negative 4th, so 10 to the 8, oops, that's a 10, to the 8 minus a negative 4 would be 10 to the 12th. And we're going to go ahead and divide 1.25 divided by 6.25, which is 0.2. So we have 0.2 times 10 to the 12th. Now that's not scientific notation, right? Because scientific notation needs a number out here. So we're going to move the decimal once to the left, sorry, to the right. Since we moved it one more time to the right, that's going to kick us up one more. So we're going to have 2 times 10 to the 13th. That's scientific notation, and in standard form, it's going to be a 2 followed by 13 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That is a lot of light. Sorry, I just caught myself. This is not 13. And actually, since we moved it to the right, it makes it go down to 11. So this is 10 to the 11th power, which knocks off 2 of those zeros. Still a lot of light.